Okay, so here we are writing an assembly language program in the 8085 simulator, and what the question demands is that 6 bytes of data are stored in the memory location starting at 2050H. Add all the data bytes, use any register to save the carries generated, uh, and the content the added content should be present in the accumulator, right? So uh, this program illustrates the use of uh, the conditional jump instructions. Here two conditional jumps are used along with the increment the register pair, uh, decrementing the counter, and incrementing the carry generated according to the carry flag. If the carry flag is set, that is, the carry is generated on the addition of two numbers, the value of the data stored in the register B is incremented by 1, and finally we get the overall carry, right? So let's proceed. First of all, what we do is we clear both the registers, register A and register B. Register A is used to store the sum, register B is used to store the carry, right? So we start at the memory location 2000 and we clear register A. The code is AF XRAA and the register A is cleared, right? Then we go next. Now as the register A is cleared, the data that it holds uh, is 0. Hence we transfer the data into register B, and uh, the register B is consequently cleared. I also tried using the A8 code. A8 opcode basically stands for XRA of B, but for some reason I don't know, it doesn't seem to work. So let's stick to mof A comma B, and sorry, mof B comma A. Move the value from the accumulator to the register B and clear the register B, right? Next, what we do is we set up a counter. For setting up a counter, we use the move immediate operation and store a value in the register C, and the value is 06 as we are adding 6 numbers, right? Now what we do is we store a memory location into the HL register pair, right? And we can increment the HL register pair for successive memory locations to access the data present in the successive memory locations in order to add the data, right? So what we do is at the memory location 2004 we use the LXI instruction, LXI of H. The opcode is 21, and what we do is we store the memory location. The lower byte goes first, so the lower two bytes 50 uh, go first, and then the upper two bytes, which are 20. Now the memory location is stored in the HL register pair, and we can access the data present in the memory location using the HL register pair. Now what we do is we add the data present in the memory location which is present in the HL register pair into the accumulator. For adding that, we use the add operation whose opcode is 86. Note that all the operations are carried out using with the accumulator as one of its registers, and the sum is stored in the accumulator, right? So the opcode is 86 and the uh, operand is the HL register pair, and the opcode and the operand make up a 1 byte instruction, right? So the total hex code is 86. Opcode is not 86. The total hex code is 86, including the opcode on the operand, right? Now what we do is we check if a carry is generated. If a carry is generated, then we have to increment the register B. If a carry is not generated, we can continue our addition process, right? So what we do, we use the jump on no carry operation. If carry is not generated, we must increment the memory location in the HL register pair so as to point to the next memory location. We must decrement the counter because we have already added two numbers, uh, and then we must proceed with the addition operation, right? but if the carry is generated, we must increment the register B, right? So D2 stands for jump on no carry, and on jump on no carry we jump to a memory location, and the memory location is 0C, as we will see when we proceed further in the program. So the memory location is 0C, right? And 200C, rather the lower byte is 0C. And then what we do is we increment the register B in case there was a carry. In case there was a carry, the jump instruction will not be executed and the register B would be incremented. So 04 stands for INRB, and the register B would be incremented. Now for that jump operation at 200C, what we have to do is we have to increment the address in the HL register pair and decrement the counter, right? So what we do, what we do is we write 23, correct? So 23 is the opcode for incrementing H. The address needs to be incremented and then decrementing, right? Decrementing the register C, which holds the counter, right? So DCRC. Right now we have to continue with our addition process. So again, we, until and unless the counter is not set to 0, note that we have decremented the counter after one addition. Until and unless the counter is not set to 0, we have to continue with our addition. So we use the code C2, which is the opcode for jump if not 0, and where we have to jump is we have to jump where we started our addition loop, and where we started our addition loop at 2007. So 07 and next is 20, correct? Next we give a halt to halt our program. Now what we do is we store our data in the memory locations starting from 2050. I have already done that. Let's check, right? So let's check, right? Examine memory 2050 and the data is 09, right? So I've already stored the data from 2050 to 2055, right? I'll press reset and go and start the program execution. Halt encountered at 2011, A stores 11 and B stores 00. So no carry is generated. Our sum, if we look at the data, was 17, and 17 in hexadecimal is 11 with no carry generated, right? So that's it. We have completed our operation.